Yay, we're live.
Woohoo! Hopefully nothing goes wrong now. It would just make for an interesting broadcast to watch.
Okay. So did you get part 1 done?
Mm-hmm. Sure did.
Okay. Um, so do you want to talk about anything, or is there anything you wanted to,
Let me look over it. Just pull it up right here. I guess one question I did have is the confidence level. I don't remember that being something that I had questions about during the reading.
Okay.
Is the confidence level, is that something that's always provided?
Hmm.
His confidence intervals were how to figure those out. But confidence levels, I'm a little bit foggy on if you need to
Okay.
figure those out or if that's like our level of significance.
Where are we talking about confidence levels at?
Um, it's in 4.1.3. Let me read over this again because I just got there too. So 95%, it's called the confidence level.
Okay.
So I think the first place I noticed it when I was talking about finding the what was it? Using the z-score, and the z-score correlated with the confidence level.
Okay.
Calculating the margin of error, that's what it was.
Let me see.
And I didn't have time to Google it before we met, so.
Yeah, that's what I'm doing right now.
Oh,
So I find the ratings.
Google is so helpful.
Mm-hmm. Confidence intervals. Oh, okay. So basically, a confidence level refers to the percentage of all possible samples that can be expected to include the true population parameter. For example, suppose all possible samples were selected from the same population and a confidence interval were computed for each sample. A 95% confidence level implies that 95% of the confidence intervals would be included in the true population parameter.
Okay.
Does that make sense?
I think so. So a margin of error is, I'm simplifying this to where I kind of understand it, but margin of sorry, margin of error is kind of that range of uncertainty.
Right. I think what you're saying is kind of your mean is you found your percentage, but
Give or take.
Give or take 3, what was it, 3%?
Right.
And I think if
Okay.
you're doing a confidence, you're saying if you're doing a 95% confidence interval, you're basically saying that you're 95% sure that the true number, like if you said 49% with a plus or minus 3 points, you're saying you're 95% confident the true number would be between 46 and 52. That's kind of what I understand it to be. Is that what you understand?
So that's the confidence interval, right?
Mm-hmm.
Okay, and then the confidence level, it's just really similar to the confidence interval.
That's what I'm guessing. I don't know if I don't know if you can
So
interchange those two sayings or.
So this is I just googled it too, and I'm looking at StatTrek. Is that the one that you looked at too?
Yes.
Okay, so confidence intervals can include the true population parameter, but it's not. But sometimes it won't. That's what I'm getting out of what it's saying there. Let me give a range of possible values of parameter. Okay. So margin of error is the estimate of kind of where we're at. It corresponds with the confidence level. Confidence level is kind of chosen, is kind of what I understand. And then after we have our confidence level, we can figure out our z-score. And after we have our z-score, we can figure out what the confidence interval is. And the confidence interval is just basically a range that it could be.
Right.
Okay. I hope that I'm understanding. I don't know. Does it sound like I have it, or?
To me, it does. Because if you go down to 414, it basically says the z-scores if you want a confidence level for 95, 99, or 90, which I mean kind of goes back to the
68, 95, 99 rule?
well, it goes back to the homework we did, number 5, where we typed in where we, instead of entering the z-score and getting the probability, we entered the probability and got the z-score.
Oh, okay, right. With the applet, okay, gotcha. So we determine our level of confidence based on something, and then with that level of confidence, we figure out the z-score. Okay.
So like, you know, if you have a confidence level of 90, your z-score would be 1.65, 95 would be 1.96, and 99 would be
Okay.
2.58.
Okay. All right, sweet.
So are you ready to do the
Part 2?
second part?
Sure, let's go for it.
Okay. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean?
So the 3 assumptions. I'm assuming that you'd have to assume that it has to be a random sample.
Okay, I'd agree with that.
Okay.
Mm-hmm.
Would you also say that you have to assume that it's normally that that we're normally distributed? Or
Mm-hmm.
sorry, that our sample mean. That's what I was looking for.
Yeah.
Okay.
Let's see. And it says, okay, so we got the first 2 right. And then it says sigma has to be known.
Our standard deviation.
Yes.
Okay.
So those would be the 3.
Go back to your room. Bye-bye.
So okay, and then if we go, the Graduate Management Administrations test is used as an admission criteria in many Masters of Business Administration programs. A BYU professor would like to estimate the population mean for a simple random sample of 50 people's score. The sample mean for these 50 students is 541. Assuming a population standard deviation of 32, answer the following questions. So what is the point estimation for the population mean? Well, it's going to be the same as this sample, right? It should be 541.
The point estimate. Yeah.
Okay.
Because I think so, yeah. Because our point estimate in this case is our sample mean.
Okay.
Now, in another in another case, though, our point estimate could be like our population mean, I'm guessing. I don't know, this is just hypothetical.
Mhm. But it isn't, since the sample's large enough, 50 students, that it should reflect the population mean?
Ooh, I don't know. Yeah, I think that it would reflect the population mean since it is 50 people. I mean, roughly. Okay. I don't know. That'll be something to figure out, I guess.
Okay, so then we have the next question.
It's to create a
So,
95% confidence interval for the population mean. Okay. Let me just get a handy dandy writing utensil.
Okay, so
Let's see. So for this, we're going to have two answers because it's x bar plus or minus.
you're right.
Okay.
So
Probability applet. Doing 95. Oh, of course, our Z. If it's 95, then our Z-score should be 2. Well, 1.96. How's that? That's what the applet says.
okay. I think I goofed. Let me see this again. Okay. So the formula should be 541 minus 2 times 32 divided by the square root of 50, right?
Yes. Unless they want you to use exactly 95% for the confidence interval. Because if it's exactly 95%, then our Z-score is a little bit different.
Because, yeah, I'm not coming up with the same answer they are. I'm really close,
Okay,
but I'm not coming up with the same answer if I use the 2.
let me try it with the decimal number.
Okay.
They got, for the first one, you got 50. Okay, yeah, that's what it is.
So it's using,
It's using 1.96 instead of 2.
.96 instead of 2.
Mhm.
Okay.
I got the same thing they did for both of those when I did that.
Yeah, so did I now. So I guess they want it right on.
Yeah, I guess so.
Well, because in the reading it's like just use 2. I guess not.
Which one should we do?
Okay.
Whichever one gets us the right
Well, that
answer.
worries me when we get to the homework. Which one should we use? Hopefully they want the 1.96.
Yeah,
Okay, so now we're changing our sample size to 100, but nothing else changes, I'm guessing.
right. That's what I understand too.
Okay. Okay. So that one I got 534 point. Well, they round up to 0.73, and then 547.27.
Okay, same thing I got.
Okay.
So the next one is dealing with margin of error, and I just realized something, and you probably already realized this, but margin of error is just the second half of the confidence interval equation.
So the 1.96 times 32 over 100.
Yeah, that's margin of error. So our confidence intervals are directly proportionate to the margin of error. So looking at
So in
this,
this case, your margin of error is 6.272, right? In the bottom one.
good question. So ho- hmm,
And 8.78 above that on the top one, I'm guessing. 6.783, maybe. From what you're saying.
I was trying to do it if I was trying to find a shortcut and it didn't work. Yeah. So our margin of error gets smaller the larger
Yes.
our sample sizes.
Right.
That makes sense, I guess. I mean,
Mm-hmm.
when you actually think about it.
Okay, so then a 90% confidence interval for the original 50. If we go to our applet, looking at 1.645, right?
One second, I was just typing in answer. Um, for a 90 confidence interval,
Mm-hmm.
1.645.
That's what I got,
Okay.
which I think is the. If you go down. Yeah. Which, if you go down to their little tablet, if you go on the reading,
Hmm.
they've got a little kind of table there that shows 90% confidence level equals a z-score of 1.645, 95 equals 1.960, and 99 equals 2.576. So they've got it kind of a little tablet, a little graph
Oh,
there.
that was nice of them.
Okay.
Okay, so now we just do pretty much the same things we did in the other one. So 541 plus and minus 0.645.
Okay, I got 533.55555, and I put 556.
Okay, I got that same thing. And then for the other one, I got 548.444.
548.4, yeah. 444.
Okay.
Okay, so margin of error.
Well, our margin of error is going to be, wouldn't it be quite a bit bigger if our confidence level is smaller?
Well, if you figure it on the math, it actually goes down. Your margin of error goes down if your confidence level goes down.
Interesting.
Because our confidence level before was 8.783, and
Right.
now it's 7.444.
Hmm.
Kind of odd, but
Okay.
that's the answer. It says the margin of error gets smaller as the level of confidence grows smaller.
Hmm. Why would it do that? Because, I mean, mathematically it makes sense,
Yeah.
but our confidence level, that's how confident we are that the true parameters are within
Right.
confidence level.
Well, I'm wondering if because you're like the first place, you're saying okay, like we're saying we are 95% confident that the true um, number lies between 532.13 and 549.87.
Okay.
So because we're more confident, we have to give ourselves more leeway. Where if we're less confident in the next one, we can have less leeway, kind of. Does that make sense?
Kind of, yeah.
Because in 11, we're only saying we're 90% confident that the true mean lands between those two. Um, so I'm wondering if because you don't have to be as confident, you don't have as much leeway either way.
Maybe. I don't know. I feel like it's all flip-flopped. I would think if you're more positive that that your mean is correct, that you would be closer to the actual mean.
Yeah, I would think so too, but
Alright,
I
well,
guess it's backwards from what you would think.
alright, well, that's okay. I'm sure he'll say something about it in the video. Um,
Okay, so how do we reverse the 13? I'm not sure about that one.
so he wants to make sure that the margin of error is 5. So we could do,
I want your son on your bed reading your
I
book. I
need
don't
to
know what
know.
How old is your son?
So what we can do is we can do the margin of error multiplied by the z-score that corresponds with 95%, and then um, let's see.
Okay.
Um, oh great.
To me, it looks like we're looking for the square root would be where our x is, but I don't know. That's kind of
Let me flip my paper over and see if I can just figure it out with the whole algebraically solution thingy. This is the one thing that I loved about my physics class, is you could figure everything out with just letters, and then afterwards you just go back and put numbers in. 10 divided by the z-score. So our formula to figure out the number would be n is equal to, and then in parentheses, the z-score times our standard deviation, or sigma, over m, and then close parentheses, and all of that is squared. I'm going to try that and see if that's right. So the z-score is going to be 1.645. Standard deviation was 32. Divide that by our margin of error, which is 5, and then square all of that. And what I got with that formula is that our sample size needs to be 110 or 111. Is that what they say? Oh, no, it's not.
Okay, that's not making any sense. So our margin of error should be 5, right?
Right.
Z-score, which is with 95% is 1.96 times 32 over the square root of x, and we want to find x, right?
I thought we wanted to find n.
Well, n, yeah, I'm just
Okay,
throwing
okay.
it up because, yeah. But
So,
yeah,
sorry.
No, that's fine. I screwed that one up.
To me, what that was.
So we divide both by 1.96 first of all, right?
Oh! Oh, I did it for 90, not 95. But yeah, so first both sides are divided by 1.96 by the z-score.
And then times both by the square root of n, right?
What I did is when I got there, I have the margin of error and z-score in a fraction type thing, and then I have the sigma and the square root of n in a fraction, so I just cross-multiplied.
Okay.
That's the one thing from middle school math that I still use. And I love it. It's the best. So that does give us the right one.
Okay, I got one. Let's see. Okay, I got 157.3519, and since you can't have 0.3519 of a person, 158.
Yes, that's the same answer I got. But would we still say, but since it's persons, as soon as we break over a whole number we round up?
That's what I would say. To me, it's going back to that middle school math again. Like, how many buses do you need to take so many students? And since you can't split a student in half, you would need a whole bus for one extra kid. You know what I mean?
Right.
Um,
That sounds more like Math 108, though. I didn't learn that in middle school.
well,
Unless
but
your middle schools are a lot better than my middle schools.
so, and that's what they have here is 158. So,
Okay. Alrighty.
do you want to try the test?
Oh, I don't just want to try it. I want to... Oh, that's... It wouldn't let me close Word because somebody else was using it. But I'm the only one on the computer. Okay, so group meeting.
Okay. Margin of error for a 90% confidence level. Standard deviation of 50. And 25. And what did we say? Oh, did I close that?
So margin of error is the z-score. And our z-score for that would be 1.645.
Mm-hmm.
Okay. And then standard deviation 50. The square root of 25. So about 16.45.
That's what I got too.
Okay. Which of the following statements is true? Oh, this is great. I think that it's the x bar is a point estimator of mu,
Okay.
but I could be flip-flopped on that.
Let me see if I can get this to load. Take a look. Are you seeing anything in the chapter on that?
I see the table. Let's see.
So X can be used to, yeah, X can be used to estimate U.
Mm-hmm.
That's the only one that lines up, so I guess that's got to be the right one.
I thought that it might be flip-flop for a bit, but it can't. Mu can't be a point estimator of x bar because x bar is a sample of mu. X bar, our sample mean, I mean, you can't have an estimate of your sample mean. Never mind. Yeah, I'm pretty sure that's right. I'm just getting myself all mixed up.
Okay. Output, there we go. Okay. So the next one we want to use the lower formula,
The which formula?
the 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 x minus 1.960.
For number 5?
Yes, because it wants the lower limit of that confidence level.
Okay. Okay.
So what'd you get on that?
So I want to see if I did it right, because I might have done it a different way. So
Okay.
what I got was 498.315.
That's what I got.
Okay. And see, all I did is I just found out, I just figured the margin of error and then did a plus and minus of what our sample mean was.
Okay. And then did you get 554.358?
I
The
got
upper limit?
550. I got 553.685.
Okay. Let me look at this again. 526 plus 1.960 times 113 divided by square root of 64. Oh, 553.685?
Yep, that's what I got.
Okay.
Okay, so confidence interval. See what would happen to the width of the confidence interval if Gina increased the sample size.
It would decrease, right?
I think so.
Because
Yeah.
back to the homework. Oh, shoot. Yeah. Okay. And then it would increase on 8, right?
Number 8 is. I think so.
Ah,
Wait.
now we're back to sample sizes again.
Have fun.
Okay. So let me do the last one. Margin of error 50 hours. So we're going to have 50 equals let's see, and they want 95, so 50 equals 1.960 times 400 over the square root of x. Is that what your formula is? Or square root of n?
No, I didn't do it with numbers. I just figured out the the algebraic one.
Mm-hmm.
And so I've just put in the z-score. Oh, but I did that wrong. So I just, here, I don't know if you can see my paper. Might me. But is it all backwards?
Okay.
But see, what I've done is I've just taken the original formula, and then I
Uh-huh.
just figured it out to right here. And so now I know that this formula, if I need to figure out the sample size, and I have the level of confidence, the standard deviation, margin of error, I can figure that out without dealing with numbers. I just have to plug the numbers into my calculator.
Okay, that makes sense.
That's what I did. And I got 246. So I guess we'll see if it
Okay, well,
holds.
let me do it the long way, and we'll see if that works.
Okay.
Mm-mm. Hmm.
Yeah, it was with a 95% confidence level, right?
Mhm.
Or interval, I guess.
Yeah, I'm not coming anywhere near to what you got. I
What did
think
you
yours
get?
is right, though, because mine's less than 1.
Okay.
So what did you have?
I got 246.
246. Okay. Okay.
This looks like fun.
Mm-hmm. Okay.
So, um, we have our confidence interval. We have our. What do you think we do on 10 and 11?
Ooh.
Do we just need to find the margin of error and then find the range of x bar, or are we finding it um, for mu? I'm a little confused here.
Okay, so your confidence level at 111,000 is, so we're trying to find the confidence level that 111,000 was correct, right? So I think we can just forget the 100,000, can't we?
I don't know. Because, see, to me, I feel like the question is asking us to figure out if that 111,000 is within the limit of a 95% confidence interval of the 100,000.
Well, we can find the standard deviation for this because we just have to go back where you do the 100,000. What is that formula?
Standard deviation over the square root of the sample size.
Right. So you do the 36,730. Right? Am I right?
I'm not 100% sure. Let me put it like that.
Well, because your full data is 100,000 with a standard deviation of 36,730. So we have to find the standard deviation for what he did, right?
I guess the question I'm asking is, are we finding are we working with 111,000 or
Well, I think
okay,
we're working with
yeah,
111, but we have to find what standard deviation to work with, and so for that we have to go
okay,
backwards.
yes, you're right. I've because that's our sample mean, and we're working with our sample mean, not with the population mean. So then our standard deviation would be 6,121.667.
Yes, 6,121.667.
Okay.
So then we need the lower limit of that 95. So we would go to now we bring back the 111,000 times 1.960 and then 6121.667 divided by the square root of 36, right? No, yes, minus, because we want the lower limit.
So for the lower limit, I got
Minus
109,000.
Yes, I got 109,000 rounded to the nearest whole number.
Mm-hmm.
I wonder if they want us to round up like before. Just as round.
I'm gonna do it to 109,000.
That's what I'm going to do too.
And for this
Okay.
one, I got 113,000.
Hmm.
It was 112.9, or sorry, 112,999.7. But if we're rounding to the nearest whole number, then it would be just 113,000.
113,000. Okay. 12.
Looks like it's all of the above.
Yep.
Okay. Submit.
Oh! What
That
did
didn't
we
sound
go
good.
wrong?
Oh, dang it.
Yeah, we missed 10 and 11.
Huh.
Don't know where we missed, but we missed 10 and 11.
Yeah, I don't know either. I kind of wish it would just tell us what the answers were immediately instead of waiting for a week.
Yes, I do too, but I guess they don't want us to run out and tell the next group or whatever, so.
Hey. Post on the discussion board. Hey, here are all the answers, guys.
Yeah, that would be